This is our first triangle question, number 6. It's asking you to classify this triangle. So the first thing we're going to do, just because it's easiest, is calculate the slopes. So from J to E, I'm going to do from 4 to 6, I went up 2. And from 3 to 7, I went up 4. So the slope is 1/2. Okay. From E to N, the slope 6 to 1 went down 5. And from 7 to 5 went down 2. So the slope of EN is 5/2. Okay, lastly, from 1 to 4, I went up 3. And from 5 to 3, I went down 2. Okay. Now, comparing all three of these slopes, what you're looking for is one pair of slopes that might be opposite reciprocals. Their product would be -1. That would mean there's a right angle in between them. And you only have to, once you've found one, you're not going to find two. All right, so because you can't have two right angles in a triangle. So there are no right angles. Okay, and if there are no right angles, then we can mark off right. We know that it's not right. Okay, so now let's look at the distances between these points. Okay, I'm going to, with triangles you end up having to use the distance a lot more than you do with quadrilaterals. It's not a big deal though. Put your x's in, so 3 and 7. Put your y's in, 4 and 6. So the square root of 3 minus 7 is -4. Square that quantity and it's 16, plus 4 minus 6 is -2. Quantity squared would be 4, so this is the square root of 20. I'm going to advise you, don't take the square root or simplify that yet. Just hold on. You want them all to look the same. So let's do the N to E. You can better make comparisons when they're not square rooted. Okay, so putting in my x's, 5, 7, and my y's, 1, 6. 5 minus 7 is -2. Quantity squared is 4. 1 minus 6 is -5. Quantity squared is +25. So this is the square root of 29. Okay. Next, we're going to look at from N to J. So square root. How many licks does it take to get to the center of a Tootsie Roll Pop? Plug in your x's, so 5 and 3. Plug in your y's, 1 and 4. 5 minus 3 is 2. Quantity squared is 4. 1 minus 4 is -3. Quantity squared is 9. So that is the square root of 13. Okay. First of all, you can look and see that none of the three that we see in here, square root of 20, square root of 13, square root of 29, none of them are the same. And so you know that this is definitely scaling. None of the two sides are the same, so it's not that. And if it's not equilateral, it's not equiangular. Okay, so the last thing we want to figure out is this acute or obtuse? Now here's where you're going to use Pythagorean theorem in kind of an interesting way. All right, and here's how it works. You take a look at square root of 13, square root of 20, square root of 29. You definitely know that the square root of 13, put them in order from least to greatest. Square root of 13, square root of 20, and the square root of 29. Now, if square root of 13 squared plus the square root of 20 squared were equal to the square root of 29, we would know that's a right triangle, but we've already ruled that out with slopes. So we know it's not, but here's the thing. If the candidate that you have right there for hypotenuse, the largest side, if it is bigger than, in other words, it's got to be huge to be bigger than the sum of the squares of the other two. Okay? If you have a giant, think about this, a big giant third side, longest side, that's because this is obtuse. Okay? If it's not a big giant third side, then it's going to be acute. So we're going to check it. The square root of 13 squared is 13, plus the square root of 20 squared is 20. How does that compare to 29? 33. And we're comparing that to 29. 33 is bigger than 29, which means the longest side is not an enormously long side. Okay, and if it's not, then it can't be obtuse. H you can rule out, because yes, we can figure it out. This is acute. So what we have here is a scalene acute triangle.